Hello.
Hello.
Seems like
Very
you're
good.
the first presenter.
Yes, now I turn on my экран. Зараз, секундочку. Yes, do you see my screen?
Yes, yes. But we probably need to wait the rest of...
Okay.
Yeah.
I wait now.
Just wait for a couple of minutes and our administrator will add to our room other participants.
Hello, may I ask a question?
Yes, please.
My section is number 1, but unfortunately the bottom is only for the room 3, and the administrator invite me to the section 3. Is it okay, or should you...
Oh, you should choose the first section. You can leave our room and the administrator will add you to the first section.
Okay, thank you so much. I will wait.
Okay, we probably will start, and then when our colleague will edit, we will see already the circumstance. If you don't mind, of course.
I can begin, yes?
Yes, sure. Yeah. We are listening to
Okay, thank you very much. Thank you very much. Our work is research on energy efficiency of Wi-Fi IoT systems on Renesas DA16200 platform. Сейчас, секундочку. Так. The purpose of the article is to compare the energy efficiency of three Wi-Fi controllers. The article aims to compare the energy efficiency of three Wi-Fi controllers ESP8266, ESP32, and DA16200 for IoT devices. IoT philosophy. The Internet of Things is the nervous system of the future society extending into every home. Just as electricity, water, gas, and heating were once brought into every household, the ideal element of such a global nervous system is a small device powered by batteries for 3, 5, 10 years or more. This device transmits and receives data to an internal gateway, automatically connecting to its cloud. At first glance, this engineering task may seem straightforward, but in practice, creating such an IoT device has proven to be more challenging than sending a spacecraft to the edge of the solar system. This is because, in addition to these requirements, the cost of such a device must be $5 or less. Additional data transmission must be well secured, and emerging trends suggest incorporating edge and fog computing to reduce the load on cloud servers and minimize traffic volume. Currently, having this task in its injury to technologically unfeasible. Essentially, the challenge is to create a high-performance element that consumes minimal energy, nearly costs nothing, and is capable of transmitting data through concrete walls over hundreds of meters. The questions arises: is it worth investing efforts in solving such a complex problem? The economic gain from the efficiency of IoT in terms of collection various data from objects seems dubious. However, it becomes significant that the IoT-generated big data enables prediction of the behavior of all physical objects. Prediction equates to control, and control equals power, in this case global power, knowing everything and managing everything. As of now, physical limitation to the widespread implementation of IoT is the power of radio signal transmission. Standard frequencies like 2.4 GHz used by Wi-Fi, Bluetooth, Zigbee struggle to penetrate walls due to very short wavelengths, requiring a sharp increase in transmission power in energy consumption. Thus, there is a trend to shift IoT to sub-gigahertz range for improved penetration, increased range, and reduced energy consumption, albeit leading to issue with non-standard gateways, Bluetooth, Zigbee for internet connectivity. The standard device for internet connectivity is the usual Wi-Fi router. However, the Wi-Fi standard was developed as high-speed protocol, consuming around 200 mAh during transmission, which is too much for battery-powered IoT. Moreover, Wi-Fi consumes a significant amount even in receiving mode due to the complex mathematics of the TCP/IP stack. Therefore, working on Wi-Fi from batteries while constantly connected to the router is possible for approximately only 2 weeks. The existence of deep physical limitation led engineers to consider the idea of long-term continuous connection of battery-powered IoT to Wi-Fi as impossible, even though everyone understood it would revolutionize IoT. This is because a Wi-Fi router is present in every home, eliminating distance problem and the need to not standard internet gateway device. However, engineers at Renesas managed to solve the low power consumption issue during reception to values in the tens of microamperes. This allows IoT to stay online with a Wi-Fi router for a year or more, depending on the battery capacity and the amount of transmitted data. The solution involved researching the Wi-Fi protocol algorithm for minimal radio contact while maintaining a constant connection to the router. The second step was to create a Wi-Fi microcontroller with maximum energy efficiency when processing the TCP/IP protocol. The idea was to reduce the processing time and therefore power consumption if it wasn't possible to reduce the current consumption during TCP/IP processing. The ARM Cortex-M4F microcontroller was chosen and fast code for TCP/IP processing was developed. This resulted in a record low processing time, only 2 milliseconds for data reception. For comparison, the most efficient ESP now code on competitive Wi-Fi microcontrollers like ICAIIT8266 has a processing time of about 130 milliseconds, roughly 70 times higher, leading to significantly higher power consumption. Renesas named this set of methods for reducing power consumption during reception and maintaining constant contact with the router the Virtual Zero technology. It is essential to note that Virtual Zero technology only saves energy during reception. Thanks to this, it allows establishing a continuous connection of IoT with the router and a record shot response time of around 1 to 3 seconds, enabling the management of IoT devices with acceptable delays. For example, it becomes possible to control locks, lighting, and other household items that execute commands while in the reception mode. For IoT devices operation in transmission mode, including numerous matters transmitting reading twice a day or less, the Virtual Zero technology almost does not extend battery life. This is because constant connection to the router is not required for such IoT devices, and the connection to the router approximately once a day, taking about a second, has almost no impact on overall power consumption. The energy consumption for transmission in the Virtual Zero technology is the same as in other controllers. Bypassing the limit of high power consumption in Wi-Fi transmission is impossible due to the physical laws of radio wave propagation at a frequency of 2.4 GHz. These waves poorly penetrate walls due to very short wavelength. Compensation for this disadvantage with high emission power. However, research can be conducted to reduce emission power since the distance within the home to the router are small, and the radio wave power from IoT can be increased by using a directional antenna. However, we have not encountered such research. Radically reducing power consumption during transmission is possible using different protocols and radio transmission ranges, with the most promising being the LoRa and 6LoWPAN system with distributed spectrum. It utilizes radio waves below 1 GHz, which penetrate walls several times better and can receive signals by employing spatial modulation below the noise level by 20 decibels. However, such system require a specific gateway for internal access. Despite the lowest consumption levels during transmission, the 6LoWPAN system has minimal transmission speed, which can drop to levels of a few dozen bits per second. This system are necessary when frequent but small data volumes need to be transmitted, such as for real-time monitoring of matter reading matter reading and over sensors. However, it's crucial to remember that these systems do not work with usual Wi-Fi routers and require the purchase a specialized internet gateway. Nevertheless, it can be said that the Virtual Zero technology is revolutionizing the IoT world as it solves the problem of managing battery-powered IoT through Wi-Fi with a delay of around a second, which was previously deemed impossible. Previously, such IoT devices constantly in reception mode connected to the router required power from a power adapter. In the IoT Mark Wi-Fi test, the DA16200 received a score of 850 equivalent to approximately 850 days of autonomous operation for IoT with 2 AA batteries. It is expected that the intelligent door lock will last more than 3 years without recharging, which 50% longer than the nearest competitor can offer. For the first time in Wi-Fi history, it can provide autonomous operation time for controller IoT comparable with ZigBee and Z-Wave. However, it's essential to remember that ZigBee and Z-Wave require the purchase of special router, while Virtual Zero technology does not. Thank you very much. I have end.
Okay, thanks for your presentation, and maybe our colleagues have questions to you. Yes, I have. Could you please explain in which subject area do you applicate or implement this controller?
Okay, this controller we implement in the smart home. It's maybe usual home, 1 or 2 floor, not large. What and most imported. It's control IoT for the time from 1 to 3 seconds, very quickly. What when we need to control IoT with very small time, its technology is very good.
Yes, but Internet of Things can't exist just by himself. For what reason do you use these Internet of Things controllers or sensors, or what? For what?
Yeah, understand. It can, как это разделить? IoT divide. IoT can divide on 2 groups. First group, this Internet of Thing, which we control this. We translate to Internet of Thing any command. It's one class. A second class, we don't translate any command to this Internet Things. What second class, it's large class who simply measure any levels and transmit these levels to cloud. This Internet of Things don't must control every second, but first group must to control, for example, locks, то есть замки, light, we must to control там.
Smart home, yes,
да,
I understand.
Control,
so
да.
you implement this controller to smart home systems.
Smart home systems for control IoT, not receive IoT, a control to transmit on IoT any commands. In this case, this controller it's very well.
Okay,
yeah.
Understand. Thanks. So your research not only theoretical, but it also has some implementation results. Yeah.
Now practical. Only check current consumption only, but usual and practical improve in smart home we don't doing no.
Okay.
But we can try this. How it will be? Therefore, internet thing who receive comment may как это очень редко this
very rare.
This internet of thing must to transmit information to cloud in this type. This controller has not any как это улучшение
improvement.
Not have only then this controller receive comment. Вот this уникал controller.
Okay.
Yes.
Okay, thanks a lot. Maybe our colleagues already formulate their questions. If not, I want to thank you and invite our next speaker.
Thank you.
Thank you, Valentin Davidov, but I don't see in the list of our participants here. Maybe we will skip it right now, and when he will be here, we will listen him. And now, Daria Kashutina, please. Adaptive clustering for distribution parameter estimation and technical diagnostics.
Hello, can you see my presentation?
Not yet. Sergey, please, could you stop sharing the screen?
Okay. Sorry. Yes. Okay.
Yes, now we see it.
Okay, good afternoon. Thank you for invitation to participate in this conference. I am Daria Kashutina. I am PhD student of National University Odessa Polytechnic of Ukraine, Institute of Computer Science. The topic of my report is adaptive clustering for distribution parameters, estimate of technical diagnostics. Automated systems of technical diagnostic are designed to detect and analyze the parameters of electronic components to complex equipment open for critical purpose. STD in the electronics can be used to access the reliability of electronic components, increasing functionality and reducing the size of electronic components leads to an increase in the volume of data and requires special method for assessing reliability. And was cause problem when assessing reliability, such as ICAIIT testing level of bimodal failure pattern. This created difficulties in selection components. Electric components are described by many parameters will change both with the object and over time, which requires accurate assessment method. The use of automated classification and clustering method helps to effectively separate components according to their characteristics. However, traditional clustering method may be ineffective in condition of high-noise data and small sample. So the purpose of this article is to develop a method for determine the parameters of experimental MDN distribution for accessing the reliability on a batch of electric components. The work was planned to solve the following problems. Evolution of noise immunity and error based on the use of adaptive clustering using the wavelet transform. Development of procedure of implementing the development method. The proposed method includes the following steps. Cluster analysts with Weber transport used to identify structure in parameter space by dividing objects into clusters based on these parameters. Adaptive clustering used to divide points into two classes or classes. Estimation of Peltier rate and estimation of DN distribution parameters. To test the method, a bench of resistors was diagnosed. The predicted parameters was the noise level and have expected change in resistance in the group. As a result, the data from the first control were divided into two clusters. First clusters was group with 1 and 8, and second group 9 in terms of noise level. As a result, the mean time to failure values calculated using the DN disruption were responsibility 4.8 years in the absence of rejection, 7.5 years to resistors on the first classes, and about 2 years for resistor for the second clusters. So we can conclude what the development method was successfully tested on resistor rejection based on noise and stability criteria. In screening noise community and reduction, the role of the rejection procedure in achieved through the use of adaptive clustering using the Weber transform. The result of the research allowed us to recommend the method for automated selection of electronic components, especially for critical equipment. Thank you for your attention.
Thank you very much, Daria. On what stage your research now? What are your next steps? What are you going to do next?
It's I think I can maybe more research, because in our work we use only a resistor of electronic components, because we have only this data, and it will be good when we can more hard electronic components like integral Kirchhoff, because this are like complex of simple electronic components.
And what is the main benefit from your research for industry? I don't know, for production, for science, or for what? What is the main goal? What do you try to achieve or improve in real world?
It can help because sorry, I'm seconds can
Don't be sure.
Because it helps us to minimize to have error parameters of our system, because many electronic components have the noise and another parameters who can change with the other parameters for the temperature, and the resultant analysis of the system can be wrong, so we can
Okay, and what is the main area of implementation of your issue in, I don't know, in medicine, in IT sphere, or
in area who use electric components. It's many now who have.
so it's for industrial companies who
Yes.
are developed some equipment, probably. Yeah. Okay.
Yes.
Okay. Thanks a lot. If our colleagues have no questions to Daria, so
I have a question.
Yes. Okay. Please.
We know noise has a level. Which level is your study?
Sorry, I can't hear. Can you repeat, please?
Noise has a level. Yes, level
Yes.
clickers or which level is your study?
What kind of noise are you researching? Sound?
Infrasound or?
No, I guess it's like a noise of not the physical noise. It's or it's
noise.
It was
or it's meaning the data noise.
Yes, because our data can change with the other parameters. It will be the wrong resistor, maybe.
Yeah,
it
so
will
it's
be
not
it's
the
not
noise
good
like
connection.
a physical parameter. It's more like a noise of data, raw data that's unstructured and could destroy the raw. So it's not like a sound. It's a noise of data.
Yes.
Is Daria answered for your question?
Yes, I have another question.
Okay, thanks. So we are moving further. Thank you, Daria, for your presentation. And next presenter, Viktor Nazimko. I saw you in the list of participants. Victor, are you with us? Could you please switch on your camera if it's possible? Now we see your screen, see your presentation.
Dear colleagues, I am Viktor Nazimko from Institute of Geotechnical Mechanics, National Academy of Science in Ukraine.
I'm sorry, could you please a little bit closer to the microphone?
Louder?
Louder, a little bit, yeah.
Let me introduce a problem of project management, which emerges in uncertain environment. The critical path in a schedule is the most important item of project management. Specific feature and attributes of any project are that it delivers a unique, individual, custom, and unusual product or result. Any project has the start and the finish, and the project team is dissolved usually when this project finishes. Project management process is deployed under certain constraints, namely scope constraints that must be coordinated with aims of the project. It was not unusual when a customer revealed some deficiency in a project product. The project budget, the second constraint. Approximately half of the projects overrun their budget. For example, the new Berlin airport has overrun initial budget several times. More than half of the project finished later than has been planned. We consider this issue when a project is deployed in uncertain environment. Next slide demonstrates a project schedule, which is an oriented asymmetrical graph. The arrow indicates the tasks, and the node corresponds to a certain moment in time. Duration of the tasks is indicated in months. For example, task A has been planned to accomplish during 3 months, etc. A critical path that is the longest chain of the antecedent tasks determines the span of the project. In this case, the critical path is the sequence of the task A, D, F, because 3 plus 1 plus 3 equals 7 is the longest period. Unfortunately, there are a lot of uncertain factors and conditions in reality: weather, crisis, pandemics, and so on. First of all, a task duration is frequently vague. So-called paired approach uses 3 estimations of this duration, namely optimistic, average, and pessimistic. However, these values have different probabilities. That is why Monte Carlo simulation provides the most reliable assessment. We use empirical distribution of the task duration as the main input parameter. Computer selects duration for every task according to probability or empirical frequency of simulate the project schedule many times, say 10,000 and even 100 times, thousands times. When the results of this simulation are integrated, we were those who emphasized not only parametric uncertainty, but as well structural one. These are probability of the tasks and their correlation to structure. Slide number 5 shows a test project schedule having both serial chains of the task and parallel. Serial and parallel chains. So far, experts emphasize the most critical path or the longest path and neglect the other critical paths as false or minor, secondary, or subordinated paths. However, life and practice has shown that these paths may replace each other, and there might be several critical paths during project deployment. Such variability of the critical paths forces to change the project management tactic several times and consider it as a disadvantage. However, Monte Carlo simulation has shown that multiplicity of the critical paths is a natural effect of the parametric and structural uncertainty. Therefore, we developed other approach to manage project schedule. The whole set of possible critical paths should be determined on the basis of Monte Carlo simulation. And probability of this critical path is to be determined. Probability or frequency. Furthermore, criticality of the all tasks should be calculated. It was considered before that number of critical paths cannot exceed the task number. For example, in this schedule, there are 11 paths. But we discovered more than 200 critical paths. Surprisingly, the number of the critical paths overran the number of the tasks by order. Furthermore, less critical tasks may locate on the most critical path. Less critical tasks locate on the more frequent critical path. Besides, the critical paths may bifurcate, trifurcate, and even multifurcate. One critical path, two critical path, 3, and more. There is a certain probability that all 6 paths have the same duration in this complex branched critical path. Such approach provided increase of the confidence during project schedule analysis and assessment. For example, 80 days duration of this project occurs with probability of 0.82. Such an approach is an efficient tool for the risk management. For example, probability of the task can radically change the critical path probability. When first numbers indicate the case when probability of all tasks was a unit or 1, and second numbers indicate redistribution of the critical path frequency after decrease of the task 9 to 0.5. The same effect causes the task correlation. When tasks 9 and 24 correlated with probability 0.8, frequency of the critical path changed. So, multiplicity of the critical path generates structural uncertainty of the project schedule, having causal variation of the two parameters. First of all, its task and certain durations. Furthermore, the critical path can branch out which provides more effective dissipation of energy and information. Having multiple critical paths is advantageous for effective project control, as it enhances the ability to manage and maintain the project's timeline within the scheduled limits. Thank you very much for your attention.
Thank you very much for your presentation. And the first general question, is your research a part of bigger research? Or what
Yes.
for are you searching for these paradoxes?
Yes, we consider not only time, but resource. We should optimize optimal number of critical paths and resources as a whole. Resources plus times.
And in which way you implement these results of your research in your organization?
We used this instrument in plants, metallurgical plants, and especially coal mine. Coal mine is a typical extraction of coal is a typical project.
Mm-hmm.
And we used to operate to control of coal extraction in the Longboard plant.
So you have industry partners on which you can use your approach in practice.
Yes, yes.
Mm-hmm. Okay, thanks. Very interesting. Maybe our colleagues also have some questions. Seems like not. Okay, thanks a lot for your presentation and the share results of your research. Then we move on further, and I invite to present. I need to check the list. Yeah. Mm-hmm. I'm sorry if I pronounce it in wrong way. Zuhriddin Muhiddinov. And the topic, enhancing the efficiency of a gas turbine through the integration of solar heat, a case study of Tashkent CHP.
Yeah, hello everyone. Well, I'm gonna share my screen.
Please. And if it's possible, would you please switch on your camera that we could see you?
Mm-hmm.
Hello. Mm-hmm.
Hello.
It's much better.
Well, My research topic is enhancing gas turbine efficiency through solar integration, a case study of Tashkent combined heat plant. And if I go to the introduction, as you know that our 25 years in our energy section, we experienced stagnation, which meant that we didn't build any kind of power plants, or we didn't find any ways to improve or increase our power production. So that's why we are currently having energy crisis, which means that our energy demand is really high than energy production. So in order to tackle this kind of problems, President of Uzbekistan created the Ministry of Energy, and so this ministry is currently focusing on using renewable energy sources. As you know that fossil fuel resources is limited, so in global scale, fossil fuels are decreasing year by year, so renewable energy sources are in the priority. So that's why our Ministry of Energy is currently stimulating using renewable energy sources in the power plants or in the households also. So if I go to the challenge with gas turbines usually consume really high fuel consumption, especially when it comes to part load condition. Fuel consumption increases dramatically in the limit from the limit of design condition. So over the years, increasing efficiency of the gas turbines are done by many science, like increasing turbine inlet temperature, or increasing compressor efficiency like this. But nowadays, our main problem is environment. Power plants are polluting our climate dramatically. So that's why we are currently researching many ways to decrease CO2 or other flue gas emissions to the climate. So that's why we are proposing the integration of solar tower to the gas turbine. Objectives of this study is to decrease CO2 or fossil fuel dependency of the gas turbine, and by using renewable energy sources. So we also created mathematical models and drew principal schemes of this Tashkent combined heat plant. Here you can see basic principal scheme of this plant, which is here. This is a compressor and combustion chamber, turbine and generator, and heat steam generation HRSG system, which is used to generate steam from the flue gases. And in order to analyze Tashkent CHP plant, we used Epsilon Pro application. Here you can see the parameters of this fluid in the every section here. And from the help of the Epsilon Professional Pro, we obtained results. And before showing the results, I'm gonna show you our proposed model. You can see here our proposed model. Here the solar heliostats are mounted to the near the gas turbine system. This is a solar heliostats, and this is a solar tower. Solar sunlight is collected to the in the one spot here, and compressed air is heated to the by the help of solar sunlight. And here you can see solar compressed air temperature is approximately 404 degrees Celsius, and by improving compressed air temperature, we can decrease fuel consumption here. So that's why we are trying to increase temperature of the compressed air. And moreover, we also mounted here heat accumulators. As you know that solar is not present in the 24 hours. So when the absence of the solar in the cloud periods or in the night, we usually use solar. We usually use heat accumulators in order to use its heat. And moreover, if this heat is not enough in order to work in a 25.1 megawatts, we can regulate our fuel mass flow here. And with the help of epsilon probe. And moreover, here you can see one of the main crucial parameter of the system, which is called solar nominal. Solar nominal is equals to T4, which is here, and minus T3 divided by T6 minus T5. This is solar nominal. This is really crucial here. You can see from the graph here, if solar nominal is equal to the 100%, our fuel consumption is 0. This is a theory, of course. In real, it's impossible. So in real, we can reach solar share up to the 50%, which means that we can decrease our fuel consumption up to 50%. It really depends on solar share, so that's why this is a really crucial in our system. And here you can see analyze of the solar Tashkent CHP. Here you can see each point, which is superheater. This point is superheater, this point is evaporator, and this is a first heater and economizer point here. Here in this graph, you can see the Carnot factor to transferred heat in each point. So in conclusion, I can say that by using renewable energy sources like solar power to the by integrating to the gas turbines, we can achieve full dependency, fossil fuel dependency. We also achieve electricity, decreasing electricity costs. And this kind of applications, I think, more environmental friendly, and this is a future way of producing energy. Thank you for your attention.
Thank you very much for your very interesting presentation. Of course, the topic of reducing carbon footprint is very on the top of discussions in whole world. Is your issue pretty flexible and could be adopted, for example, in other plants in your country or abroad? Or it develops only for this special Tashkent plant?
No, it can be this. Our work can be used in any plant in the world or in our Uzbekistan system. But for object of the work, we choose Tashkent CHP. And the reason we choose Tashkent CHP because its load is 28.1, which is lower than others. And this work is developing step by step. And when I read other books and other scopes, research topics, they didn't apply the system to the high power outputs. So that's why I choose lower power output of Tashkent CHP.
What kind of constraints could be for implementation on another plants? Do you have, for example, some regulatory constraints because of you have no law or I don't know, some reglement or special rules from your government that you must use or you don't
regulation. No, we don't have any regulation problems. As I mentioned before,
yes.
President as a proposition of the President, the Ministry of Energy is created, and so our Ministry of Energy is currently stimulating using renewable energy sources, but main problem can be investment costs. First, investment cost is really high, but it can be used in a long term. And so main issue is, of course, first investment cost.
And what kind of renewable energy sources could you also use? For example, wind or water energy sources? I'm sorry, I'm not really familiar with the conditions in Uzbekistan, but I know that in Kazakhstan there are a lot of windmills. And in Uzbekistan, could you use also?
Yeah, in Uzbekistan we also can use wind power technologies and sunlight power technologies because our region is sunny in 300 days in a year. Yeah, we can use many different kind of renewable applications, but when it comes to gas turbine system, we can only use solar system.
It's more profitable. Yeah. Okay, thanks a lot. And we already have a question from Victor Nazimko.
Which perspective for energy storage in your country?
Can you repeat again, please?
The problem of energy storage in your country. Which perspective?
Do you have,
for example, compression air station or powered hydraulic station? Storage of energy.
Yeah, when it comes to storage of energy, we usually store energy when sun is present, usually in the day, and in the absence of the sun, we can use accumulated heat in the night or in the cloud period. And if this period is a bit longer, then it can be a bit problematic because this accumulated system cannot supply heat for a long time. But as a solution, we can regulate fuel here. We can increase fuel mass flow.
Thank you.
So the whole energy that you collect, let's say, you used during the night or during the some processes.
Yeah.
So you don't have additional solar energy that you could probably, I don't know, to use for electricity supplying in your administration building.
Yeah,
so
we
you
can
use this energy only for the process.
Yeah, if the period is a bit longer, as I mentioned before, we can use the system as a traditional way. This way, we can improve the mass flow of the fuel. I think you asked this, right?
Not really. For example, if we have additional energy, so you can store it and use it for in other applications. For example, for supplying energy, I don't know, in a residential area or for cities, for electro supplying of, I don't know, shops, buildings.
Yeah, of course, yeah. We can use, if we have excess energy or excess heat, maybe we can use this excess heat to the residential households or the buildings to heat them.
Okay. Yeah, that was a question and you already answered. Yeah, Victor, are you satisfied with answer?
Yeah, thank you.
Thanks a lot. Maybe other colleagues also have some questions. No. And thanks a lot again for your presentation.
Thank you.
Probably we will ask to present our next presenter, our next colleague. I saw him. So it's supposed to be Viktor Kuchar, but I believe that instead of him will be Andriy Bondarenko.
Yes, I'm here. I'm going to make my report. Yes.
Okay, thanks a lot. So please invite you to the board. And your topic, substantiating the chat agitator parameters for dredgers. Okay, I'm not really familiar with this topic.
Yeah,
it will be a surprise.
specific topic.
Okay.
Okay, do you hear me? Do you see my presentation?
Yes, but if it's possible, a little bit louder and maybe closer to your microphone.
My microphone is very close to me.
Okay. So maybe a little bit. Okay.
Okay, I welcome the participants of the conference, and I would like to thank the organizers for the opportunity to make my report. Let me introduce our research work. Name is substantiating the jet agitator parameters for dredgers. Researchers participated in the study Andrei Bondarenko, Viktor Kukar, Dnipro University of Technology, Dnipro, Ukraine, and Arsen Nurmanova, Sapphire University, Almaty, Kazakhstan. The purpose of the work is to develop a mathematical model of the underwater phase formation by jet agitators, helping construct a contact surface of the turbulent washing jet with the granular minerals being washed out. The development of such a model makes it possible to substantiate rational structural parameters of the dredger's soil suction head with the jet agitators. The mathematical model has been constructed in accordance with the previously developed physical model. In this research, we consider an inclined water turbulent washing jet, separating particles of grain soil and shaping a bottom phase. A water jet flows from a nozzle with radius R into the grain soil formation where particle size is the average. The nozzle is installed at the surface of the reservoir bottom. A general view of the process is shown in a figure. Due to the change in the lead section of the flow along the length, fluid flow movement in the main section of the underwater jet washing zone is smoothly varied. It has the following characteristics. Centrifugal forces are not taken into consideration. Lead flow sections are treated at the planar ones. Projection of the flow lead sections on a plane perpendicular to the axis of the jet is a circle. Vertical flows are not taken into consideration. The equation to determine the main section length of the washing zone is shown here. The correspondence of the mathematical model to the actual physical picture taking place in the underwater phase of the turbulent jet becomes possible if empirical coefficient K is introduced into the dependence. Analysis of the empirical proofs obtained as a result of early experimental studies using the developed laboratory facility helps formulate a type of dependence of the coefficient K upon the initial velocity of the liquid flow from the nozzle and the angle of inclination of the jet axis. The equation is shown here. The mathematical model helping us set the values of a sufficient number of geometric parameters to design the contact surface of the washing jet with the grain soil based on empirical models is shown here. To improve visual control and the possibility of perform appropriate measurements of the washing zone formation for underwater surface using a water jet in a grain soil, a laboratory facility was designed. General view of the laboratory facility to study soil underwater washing process by a water jet is shown here. Numerical values of the empirical coefficients were obtained as a result of experimental data processing during the study of soil washing by an inclined turbulent jet in the underwater phase. The procedure was studied using laboratory conditions when a turbulent water jet was applied to the sand of medium grain size, the average of 0.265 millimeters, with the slope angles of 15, 30, 45, 60, 75, and 90 degrees, and the diameters of the washing jet nozzle being 1.25, 2.0, 2.8, and 4.0 millimeters. Figures here and here represents graphically the empirical dependence and experimental values. For example, it concerns length of the washing jet main section from the initial velocity of the liquid flow from the nozzle. Analysis of the graphs was assured that increase in the initial velocity of the flow result in the increase of the studied parameters. Moreover, they have a linear function within the specified velocity range. The developed mathematical model to calculate jet agitators was tested while designing such ejector dredgers, very specific ejector dredgers, as the NS630-90, and updating dredge suction devices of other different shallow dredgers, for example, MZ16, MZ8, MZ11, Pichora, and FPP11 dredgers. Soil suction head of the jet pump dredger with the jet disintegration system is shown here. The ejector dredgers, the NS630-90, are unique machines designed for extraction and dredging construction works under the difficult mining and geological conditions. When, if coarse gravel occurs in the ground, if offshore operations are required, and operations take place at shallow depth. Jet pump dredger, the NS630-90 at a mining site in Liberia is shown here. The developed mathematical model calculating jet agitators has also been used to modernize the suction head of operating dredgers. For example, offshore hopper dredger Pichora and river specialized land loader FPP11 are the examples. Suction heads of the mining vessels have been upgraded by jet agitation systems. So models of the upgraded suction heads with the jet agitation systems are shown in this slide. Use of jet technologies to intensify soil washing in the underwater phase has made it possible to modernize the dredge suction heads with minimal interference in the design of the facilities. It is also important that such modernization needs neither specialized equipment nor personal qualification. Moreover, it can be performed by the mining company in accordance with the current relevant standards and regulations. Pichora and FPP11 dredgers updating has increased significantly their performance capability and efficiency of mining operations. Quantitative factors are being processed and improved. Thank you for your attention to our work. Да, Марина. Unfortunately, I don't hear you.
Sorry, we with colleagues just discussed so interesting implementation, and unfortunately, as I understood, in Ukraine it's impossible to implement it.
It was implemented in Ukrainian quarries.
In Ukraine, what? Sorry?
For example, this kind of suction head was implemented in the specialized dredger, the NS630-90, and this was implemented in the Ukrainian quarry, Ukrainian mining enterprises.
Okay, because we discussed so interesting issue. Yeah, because I saw on the slide Liberia.
Yes, and here you can see the same dredger, but it was implemented in the Liberia facility.
Sorry for interruption. Yeah, please.
It was the same machines. And here you can see only the suction head device.
So as I understood, that's all that you want to present?
Yes, I've done already, yes.
So if our colleagues have a question, because it's not my topic of research, so I can't unfortunately ask anything. So I can ask only general questions. If our colleagues have some questions or notice or I don't know, maybe suggestions to your research, next research. Okay, seems like it's not. Thank you very much for your presentation.
Thank you for the opportunity.
Thanks a lot. So, we have a coffee break at 2 o'clock, 20 minutes. But I suggest to continue our section because I see here two people that's supposed to present after coffee break. Yeah, and the first of them, I'm sorry if it's not a good pronunciation, Sirojidin Toshpolatov. Sirojidin Toshpolatov.
Yes, I'm here.
Are you ready to present right now?
Yes, I'm ready.
Yeah, okay. That's super fine. So maybe we will... You and the next also here. Okay.
І ти можеш туди поставити твого персонажа, і він ще буде рухатись.
I see that in the program it's a little bit it's another name of the topic.
Okay. Hello everyone. Thanks for being here. My theme is analysis of electric and thermal efficiency of crystal silicons. I have another presentation. I have a fall. I'm sorry.
Yeah, that's why I'm asking you that I have another topic, effectiveness of photoelectric systems.
Yes.